Welcome back, my name is Shem, and for this video, we're going to talk about the different forms of a complex number and how to plot them in the Argand diagram. Forms of complex numbers. Rectangular form. It follows a plus b times I. In the Argand diagram, a is the real part and b is the imaginary part. The rectangular form is best used in addition and subtraction of complex numbers. Polar form follows r times cosine of theta plus I times sine of theta. The polar form uses the graphical property of a complex number. In the Argand diagram, r is the absolute value or modulus. This is the distance of the number from the origin of the complex plane, while angle or argument theta is the angle that the number makes with the positive real axis. The rectangular form is best used in division and multiplication of complex numbers. Last is the exponential form. Follows r times e raised to I times theta. From Euler's formula, e raised to I times theta equal to cosine of theta plus I times sine of theta. Exponential form was taken from the polar form. This is just a more compact version. The exponential form also uses the graphical property of a complex number, where r is the absolute value or modulus and theta is angle or argument. The exponential form is best used in division and multiplication of complex numbers and in finding complex roots. We have here the three examples of complex numbers. Let's try to plot them in the Argand diagram. For the first one, it does not have a real component or the real part. For the Argand diagram, that's in the rectangular form a plus b I. A is the real part. This is the real axis, positive real axis and negative real axis. This one is your imaginary axis, positive imaginary axis and negative imaginary axis. For the first example, this can also be written as 0 plus 3i. But the correspondence, the real part is 0, so that would be here. And the positive component or the imaginary component is positive 3i. This is your complex number. For the second example, you have your real part equal to 2 and your imaginary equal to 3i, positive. So this is your second complex number, 2 plus 3i. This is 3i. For the last example, this is negative 2 for the real part and positive 3i. Negative 2 plus 3i. That is how you write complex number or plot complex number in the Argand diagram. Now we know the different forms of the complex number and how to plot them in the Argand diagram. For the next video, I'm going to teach you how to transform a complex number from its rectangular form into its polar and exponential form. If you like this video, don't forget to hit the like and subscribe button and turn on the notification bell.